We want to calculate the volume delimited by the following surfaces. We have z equal to x plus y, then we have x times y equal to 1, x times y equal to 2, y equal to x, y equal to 2x, and z equal to 0. And we know that x is greater than 0 and y is greater than 0. So what is the volume defined by all these surfaces? So it might seem complicated, but it's not too complicated. Let's try to sketch something here. So I have my z-axis, my x-axis, my y-axis here. And if I want to draw, for example, let's start with z equal to 0. Well, of course, this is the easiest one here because it's just the xy plane, right? So I have to start from the xy plane, and then I have, for example, y equal to 2x. And if I consider only the xy plane, this is just a line. This would be a line with certain slope, which is twice the slope of y equal to x. So this line will become a plane. If you consider this to be true for every z, this means that we have a plane like this. And then y equal to x is something similar. We have another plane, but the slope of this line is smaller. So we have something like this. And then we have two hyperbolas, this one and this one. If I consider them on the xy plane, I have something like this for x times y equal to 2 and something like this for x times y equal to 1. So we have to draw a hyperbola like this for every z. So this will become not a plane, not simply a plane, but it's some kind of a curved surface. I'm just trying to sketch it so that you can easily comprehend, but I'm not going to reason on this sketch for too long. This is just for the sake of intuition, then we are going to make some more precise considerations. And finally, we have another plane, z equal to x plus y, and if you consider, for example, z equal to 0, this will become the line y equal to minus x on the xy plane, so it is something like this. And then if you let z vary, for every z, you're not going to get a plane that is perpendicular to xy, but you're going to get a slanted plane. So let me do it in red, because this could be a little bit complicated to draw here with all these lines. So I have something like this. It's a slanted plane because in this case also the z coordinate appears. And for example, if z is equal to 0, we have to start integrating, and let me do it in green here, over this portion of the xy plane here, which is delimited by two lines and two portions of hyperbola. This one here and this one down here, whereas the lines are this one and this one. Then I have to consider also the portions that come out of the xy plane, and I have to go all the way up to the plane that I have drawn in red here. This plane here, z equals x plus y. So the first integral that I can compute is over z. That's easy. So it's a triple integral if you want, but the integral over z goes from 0 to this value for z, because z is equal to x plus y when I'm on the plane that I have drawn in red. So it's integral from 0 to x plus y of dz, and then I have dy dx, and I have to choose the proper limits of integration for x and y. So this will become an integral like this. It's double integral x plus y dy dx, and we have to choose the limits of integration. So now it's simpler because I can just consider what I have on the xy plane. So I have to consider only that green portion of the sketch that I have made there. Let me do it below. I have y, x here, and then I have to draw the hyperbola y equal to 1 over x, which is something like this, and then I have the hyperbola y equal to 2 over x. This is y equal to 1 over x, which means that y times x is equal to 1, of course. Then I also have two lines. I have the line y equal to x here, and then I also have the line y equal to 2x here. And now I have to integrate over this area here. In order to do that, I need to find the coordinates of these points. This point here, this point here, this point here, this point here. This is a simple task because, for example, let's call this point A, let's call this point B, let's call this point C, let's call this point D. If I want to find, for example, the coordinates of the point A, I have to make a system where I consider the line y equal to x and y equal to 1 over x, and I have to make a system out of it because I need to find the point which lies on the curve y equal to 1 over x and also on the line y equal to x. So this is how I find the coordinates of the point, and it's easy to see that I will get the x coordinate of the point A equal to 1 and also the y coordinate of the point A equal to 1. You can do something very similar for the other points. So let me skip that. This is just a very simple algebra, but let me give you the coordinates. So the point A is characterized by the two coordinates 1, 1. Then we have the point B, which is characterized by the coordinates 1. So the x coordinate of B is exactly the same as the x coordinate of the point A. And then I have 2, whereas C is characterized by the following coordinates. We have 1 over square root of 2, square root of 2. And then I have D, characterized by the coordinates square root of 2, square root of 2. So if I want to calculate the integral above, if I want to integrate over y first, then I have to split the integral into two integrals because I have to go from C till this vertical line here. So I integrate from the hyperbola 1 over x to the line y equal to 2x, and then I'm moving over x from x equal to 1 over square root of 2 here till x equal to 1. So that integral will be, the first integral will go from 1 over square root of 2 to 1. Then I have integral from 1 over x to 2x of the same function x plus y dy dx. And then I have plus something similar here. So I will go from the coordinate 1 here over x to the coordinate x of the point D, which is square root of 2. And then I have to integrate from the line y equal to x to the hyperbola y equal to 2 over x of the same function x plus y dy dx. And now let's integrate over y. This is quite simple. Integral from 1 over square root of 2 to 1 of, we have x times, when I integrate this quantity, this is a constant with respect to y, so I have x times y, and if I evaluate y at the boundary, I have 2x minus 1 over x, and then I have plus, the integral of y is y squared over 2, if I integrate it over y. So I will get 2x squared over 2 minus 1 over x squared over 2 dx, and then I have plus the second integral here, this one, will be integral from 1 to square root of 2. When I integrate x over y, I get x times y, and if I evaluate it at the boundary, I have x times 2 over x minus x, plus integral of y over y is y squared over 2, so I get 2 over x squared over 2 minus x squared over 2, and I have to integrate this over dx. So this is quite simple. I have integral 1 over square root of 2 to 1, 2x squared minus 1 plus 2x squared minus 1 over 2x squared dx plus integral from 1 to square root of 2. I have x times 2 over x, which is 2, minus x squared plus 2 over x squared minus x squared over 2 dx. And now it's quite simple. So I have that this is equal to integral from 1 over square root of 2 to 1 of 4x squared minus 1 over 2x squared dx plus integral from 1 to square root of 2 of 2 minus 3 halves x squared plus 2 over x squared dx. Now that I have collected all the terms, I can integrate over x and evaluate the result at the boundary. So I have 4/3 x cubed from this first term. If I evaluate it at the boundary, I have 1 minus 1 over square root of 2 to the third power here. And then I have minus, when I integrate 1, I have x, and if I evaluate it at the boundary, I have 1 minus 1 over square root of 2 plus 1 half. Now the integral of minus 1 half times 1 over x squared is plus 1 half times 1 over x. So if I evaluate 1 over x at the boundary, I get 1 minus square root of 2 here. Plus, and now I have to evaluate the second integral here. This will be 2 times square root of 2 minus 1. And then I have minus 1 half, because the integral of 3x squared is x cubed. And if I evaluate it at the boundary, I get square root of 2 to the third power minus 1. And then I have minus 2 times 1 over x evaluated at the boundary here. Because I have to integrate 2 over x squared. The integral of 2 over x squared is minus 2 divided by x. Here I have 1 over x evaluated at the boundary. 1 over square root of 2 minus 1, just like this. Now here I have very simple algebra. I will skip the calculation because it is very simple, and you can see for yourself that this computation yields square root of 2 divided by 3 times 2 square root of 2 minus 1, and this is the result of the integral.